Okay, hello, and welcome to Unevenly Distributed, a series on real-time data lakes. I'm one host, Josh. I'm here with my co-host, Robert Hodges of Altinity, and today we are joined by Viktor Kessler of Lakekeeper to talk about really data without borders, right? And agnostic data agnostic lakehouses. So, Victor, hi, welcome. Please introduce yourself.
Hey, Josh. Hey, Robert. Yeah. Hi, guys. Hi, everyone who's listening and watching. And thanks for that opportunity to talk at your podcast and maybe just a couple of words and short introduction. Victor, right now I'm based out of Basel, Switzerland. I'm a co-founder of Vakamo, a team behind the open source REST catalog Lakekeeper, and I'm happy just here to talk about Apache Iceberg.
Awesome. Can't wait. Yes. Iceberg has been a very interesting topic for me. I am a huge fan of open formats broadly, and just, there was a slide at one of the presentations yesterday. I'm here at the Apache Software Foundation's Community Over Code, and the slide was, it's all about interoperability. And I just love that, right? Like that's really what open formats enable and empower, and it's awesome. Okay, so Victor, let's start just a little bit more about your background and like kind of how we got to where we are. So you've been building data systems for a decade. What are some of like the pain points that you've seen in the last 15 years of Lakehouse and data system evolution?
Oh gosh, that's a long list, I guess. I don't know, like if we have enough time to go through all of them. But maybe let's just pick like two main things what I actually saw repeating all the time, and it's kind of like a combination from a technical perspective and from a business perspective. Well, the first one is a as a locking, and the pain is when you start to build some data system, and like from my background, and I'm talk like kind of like in IT archaeology. I saw that data was created in mainframe DB2 IMS system. Then we got some kind of a client server with Oracle, and then we got some data warehouses and big data system, and then we got something else. But every time we need to migrate the data, and that was a huge thing because you need to think about like, oh, I have now a format what understands DB2. And now I need to move the whole data because now I have Oracle, which is a great system and probably can scale. And now I need to move a system, my data again and again and again. And the thing is, like you can actually see that you start to build a system, and after 3 years, you need actually to think about how you're going to move that data. And it is very expensive, it's very painful, and it's kind of like one of the main main thing what I see right now. Like we can actually solve with Iceberg.
Okay, okay. So Iceberg is the solution. All right, so let me kind of step back then for those who haven't heard of Iceberg, right? Like I'm immersed in the space and I keep hearing about Iceberg and I'm a little bit obsessed with it. But then I also kind of hear it mentioned in the same breath as these other catalogs, right? Like people are always like Iceberg, Delta Lake Hootie, and it's almost like they're interchangeable. So can you tell us like a little bit about the
Yeah.
differences and what are these things and how are they different?
Yeah, let me even go a little bit back in a history, and you will see that I love history. It's why like the archaeology is somehow in my mind. So what we had our data warehouse vault, and then it was nice just to keep all that enterprise data from SAP, from Oracle, whatsoever. When we understood around like 2000, and we got internet, that we have a huge amount of data that doesn't fit anymore inside of a star schema or Snowflake schema. And what we need to do is we need to develop a new type of a system, like so-called big data, Hadoop, and Hive Metastore, ORC files. At the same time, the data warehouse vault was not sleeping, and then they actually reacted to new type of technology, cloud. Oh, now we can build something in a cloud, and it's why you saw the rise of Snowflake and then Redshift system where you can run huge amount of data. And what they done, they decoupled data and compute, so you could actually store as much data as you want, and then you can provision as much compute as you need for your application. And that was probably kind of motivation for the big data team community to develop similar stuff, and it's why we've got some kind of new players like Databricks, Trino, Dremio, and they develop their own Parquet and to allow you to store infinite amount of data. And then what we actually understood, oh, cool, we have data warehouse, but it's not able to cope with amount of data. But it's super easy to run us, and we have transactional guarantees and asset transaction, schema evolution, all that nice stuff. What we do miss in data lake world, but we can store as much data as we want, and it's kind of like easy to scale and run petabyte scale type of applications on that data. So, and luckily the community, and probably we can mention Databricks as well here, they came with a term Lakehouse, so we can actually get both worlds into one. And to solve this, we should actually think about like how to achieve something what we have on a data lake that will allow us to have a transaction guarantees. And the main thing was, okay, now in data lake we have open formats like Parquet or C, Avro, JSON, CSV maybe. And what we need open tables, and that is exactly the moment when we got the definition like of Hoodie, Delta, Apache Iceberg, where Databricks was trying to develop Delta tables that actually not a table inside of a classical database. It still lives on your data lake, but provides you the experience that you can manipulate data through SQL. You can now just go and do some deletes and updates, what was not possible on top of a Postgres, on top of a Parquet files. But from feeling it's like you work with a simple Postgres right now. And maybe just to summarize the whole Lakehouse, what was created here is there are three main components: storage, which is object storage, and it can be everything from Amazon S3, Google, Azure. It can be on-prem storage as well, from Dell, Pure Storage, Huawei. And that was the first component. The second component is a compute. And here as well, it's a huge list of different computes depending on your use case. So you're more on ETL, then you will go to Spark. You're more on analytics, you can take something like Lakehouse or like Trino. And that was quite interesting because now we have that type of component, the second one. And the third one is quite interesting, is a catalog which is required, for instance, for Apache Iceberg. On Delta, it's different, but for Apache Iceberg, that component was required. But taking that into account, so we have those three components, and then we have three main players at the beginning: Hoodie, Delta, and Iceberg. Now we can argue like which one is kind of like the main one or the most dominant. We still have three of them, but Iceberg seems to be, well, at least most popular, and provides us exactly the experience, as I said, to work with data as is just a Postgres database, but we don't have any database at all.
Hey, I have a two-headed question if I can jump in on
Yeah,
that.
sure.
First, this is a really trivial one, but it's one that comes up a lot. Do you say data lake or do you say data lake house? And
Oh, I actually say
what is
Lakehouse.
you say lake house? So do you think that's the term of art that we should be using to describe these systems we're working on?
Well, who am I to define that? But that's something what I use, right? So that's my
Right.
opinion, to use a Lakehouse as a term. Yes.
Yeah, because it's sort of the data versus data
Yeah.
controversy, which I don't know if you've been around long enough. I actually had to teach a class where I became completely confused about the pronunciation halfway through, and it was not a pretty sight. But I think either way, it seems to me that data lake has, because of the, partly because of the great Databricks paper, I think back in 2021,
Yeah.
people, when they say data lake, they're really thinking about a data lake house today. So I
Well,
see them as somewhat
yeah.
equivalent.
I mean, we can run a poll maybe, and then just
Yeah,
understand what is exactly like the current state. For me, it's like there's a data warehouse world and there's a
yeah,
data lake, and data lake
yeah,
is particularly for a file like
yeah.
Parquet. And if we have an open table format, then we will just, because we just trying to say, oh, we want to combine data warehouse and data lake, and then we just trying to take a house from data warehouse and
Yeah.
lake from data lake, and it's why
Oh,
I have a lake.
it was a
Yeah.
good marketing term.
Oh,
The
absolutely.
second
Thanks.
part of the question is following on this lake house. So Databricks, sort of Reynolds, Matei, Ali, they present in that paper that they, where they introduced Data Lakehouse, they presented this really comprehensive vision about how we would combine these parts together that you're describing. At the same time, what the open table format that seems to be winning is Iceberg, and which didn't have that vision, but instead developed because of specific problems at Netflix with Hive. And I wonder if you can comment a little bit on why it is you think that Iceberg seems to be in the lead, and what that bodes for people, what that means for people building systems today.
Yeah, so that's quite interesting, and I thought about that type of a topic, why actually Iceberg now is so popular, and I would say Iceberg has won already. That's kind of like my position, but who knows? We are in attack, and like it's all fast. But right now, I would say following. There's a main component what Iceberg did, because Iceberg is a groundbreaking standard about how you want to store the data. And there's one thing what Iceberg has is it is a part of Apache Foundation. It's open source. And I think that that is something what we saw with Iceberg, because community was just adding more and more features and was just jumping on that way how to build the stuff. And what we've got, it's not just about the interoperability of Iceberg, it's about independent way of Iceberg. And it's why Iceberg right now it's quite popular, and it's the way how we can use it. And I think that was something what on Delta Lake didn't happen at that time, that Delta was kind of like open, but still not completely open. And then they opened a little bit more. And that was probably an issue with Delta Lake, where Iceberg was open from beginning on, more or less. And that's kind of a result, what I would say.
Great, thank you very much. Yeah, it's a really interesting evolution, and I think, and now it seems that these two worlds are now combining. Once the Iceberg folks joined Databricks, so it's going to be interesting to see where that goes.
Oh, absolutely, it's quite interesting. One thing what we need to keep in mind is we still talk mostly about the structured data. And that's maybe, I don't know, like 30 or 40% of entire data volume what we have. It's roughly 150 zettabytes of data, and we expect to get to 2000 zettabytes of data pretty soon. And the question is like how Iceberg is going to evolve towards the unstructured data. So we see already the data type variant for JSON type of a workload, and then I don't know, like about all embeddings and like AI type of a data. So if that's going to be part of Iceberg, that's quite interesting. Yeah.
So we mentioned the Databricks acquisition of actually Tabular, which was for $2 billion a little more than a year ago, last June. What does that mean? Like, is that part of why we're now seeing Iceberg winning, because one of the backers of the other formats just sort of decided to go all in on Iceberg?
Oh, that's a multi-dimensional question, I would say. So you can approach that from a different perspective, from a competition side between like Databricks and Snowflake. You can say that then kind of like understanding the size of Iceberg itself, because I would say if you look at Iceberg, then Iceberg is just bigger than Databricks or Snowflake or even like Amazon Data, or something around the Google. It's why everyone now tries to jump on that train with Iceberg. And we will see more or less a migration now away from a classical data warehouse to Iceberg. So in a next, I don't know, like 3 to 5 years, we're not gonna get any data warehouse based on Postgres. Even though now we saw the acquisition of Neon and Crunchy Data from Databricks and Snowflake, and here is an interesting aspect to look at how that story is going to evolve. And for instance, the last one, independent Postgres kind of a company, is Enterprise DB. And even Enterprise DB is right now developing a platform that allows you to offload Iceberg or to offload Postgres to Iceberg directly inside of a platform. And for instance, like Enterprise DB does use Lakekeeper, our catalog, to do the whole stuff, but that's that vault of Postgres and Iceberg, they all tied together. It's quite interesting to see.
Yeah, this is sort of fascinating how this is rolling out, because I think that we're seeing people increasingly using Iceberg as primary storage for these systems, as opposed to using closed storage the way, for example, our database, the one that we work on is ClickHouse. It has its own proprietary format, even though it's open source, and ClickHouse is a gatekeeper for access to it. So, I do you think that, I mean, maybe you could comment a little on some of the issues that you see in pursuing Iceberg in this way, because it was not meant, and Dan and Ryan Blue, they will be the first people to tell you it was not meant to do this. It was meant to replace, to deal with Hive. And so what's your take on how successful Iceberg is going to be as a primary storage format for this data?
I think it's like the best things in a life that has not been planned or somehow, but they got into something, right? And Iceberg was probably not meant to be this type of technology as it became at the end. But I would say there are different things on Iceberg. Well, the first thing is probably it's still evolving, which means it is not that mature on some points, and that brings some complexity how to handle the whole Iceberg. I mean, on the first day, everyone is happy that, oh, now I can read and write Iceberg, and now it's like, oh, I solve all my problem. I don't need to migrate data anymore, and if new tool will arise, then I can just go and read the Iceberg table or write to Iceberg table. But the realization is on a second day. Like it's like on a party. First cocktail is fine, but the next day, when you wake up, you have just kind of a handover. And the thing is on Iceberg is that on the second day is you need to think about the maintenance of your table. You need to think how you're gonna compact your table, how you're gonna expire snapshots, and it's all not automatically existing yet. So, for instance, again comparing with Postgres, no one is now thinking about how to vacuum the Postgres. It's all done by Postgres itself. And on Iceberg, it's not existing today. So which means the data engineering team needs to think about that, unless it's just going to be, again, some sort of a data swamp. So non-tool like ClickHouse is not able to go and read it because we have, I don't know, a billion of 1 KB small Parquet files, because now I'm streaming the data. So that's a very important thing what every data team needs to think about, like to maintain the Iceberg table. And maybe to mention the second thing is because of that architecture, as I described before, we have like storage, compute, and catalog. Now you have a lot of different compute. So if you want to write Iceberg, you will use Spark and Pi, Iceberg, for instance, and then you want to read Iceberg, you can use like ClickHouse for something big, and then some engineers who want to use, I don't know, DuckDB or whatever. So which means me as a data security is now asking how I should manage the data governance here, the access governance. It's not trivial. And that is like the next thing what we need to think about, like how it's gonna be secured, the whole access. And there is one thing where we can say, okay, I have a system, and if it fails, no one can read and write. But if the system fails and everyone can read and write, that's kind of a disaster, I guess, from an enterprise standpoint. Yeah.
Right.
Can we just real quickly before we dive into more deeply, can we kind of define what is the scope of governance in the context of a database? Like, we're not talking about rules and regulations necessarily.
No.
We're talking about like policies for data storage, right?
Absolutely. That's kind of a main topic maybe for us from Vakamo and Lakekeeper, because it's where we trying to focus on. And we have a classic way of data access, what we can say like access governance. So I have a fine-grained access controller, FGAC, and then I want to just go and say, okay, there's a customer table and marketing can read. But sales probably shouldn't go directly to that customer table. So I just want to have a way how to allow someone to read and write data. And then it can be like on warehouse level, it can be on namespace level, on table view level. And usually the next would be column and row filtering, column masking, row filtering. And it is practically all solved accept the color masking and raw filtering today, but there are good proposals inside of Iceberg community, and we need to wait a little to get there. And solution is quite interesting. Like what we picked, our idea is not to bundle the authorization inside of Lakekeeper, but to have it outside of Lakekeeper, and we use OpenFGA, which is another quite interesting project based on Google Zanzibar paper, and it's a relational based access control, a kind of a superset from ABAC, AirBAC, and all the different bugs. And another approach is to use Open Policy Agent, which is a great tool to secure the access. And this is a classical thing. What we do have now is so-called a compute governance and context governance. And I don't know if you want to dive in that topic as well. It's something what kind of like got just because we have a Lakehouse in AI.
I'd be really interested in hearing you go a little deeper on the access control, because one of the things that databases have this rich role-based access control that has evolved over like a period of decades. So, for example, being able to restrict whether a user can see a particular row of data, so the granularity is potentially very, very fine. And then, of course, rolling upwards all the way up to, hey, can I see tables? Can I manipulate tables, do DML? How does the access control, that you're describing, how does it match up with this RBAC that people know and expect if they're building enterprise applications?
Yeah, absolutely. So here's kind of a technical limitation. If you will look at Iceberg itself, you have actually two layers. You have a meta layer and a data layer. And data layer is just a Parquet file, for instance. And if you will take, let's say, Lakehouse, and Lakehouse will communicate with catalog and saying like, oh, I want to read a customer table. And catalog will say, okay, location of that customer table is on S3 : / something. And catalog will issue you a vendor credential, so you from a Lakehouse can go and read that table. So what you will do eventually, you will go and load the Parquet file. But now your question is like, oh, I want to actually have a raw filtering. So I want to filter by country, because now the country manager from Germany should see the data from Germany, for instance. But you offload it with Lakehouse, the whole Parquet file that might have data from, I don't know, US. So how to solve that? And here are different concepts. And right now what we can use is a concept of so-called trusted compute, which means me as a data platform engineer, I will create my Iceberg table, and I will give access to a trusted compute. And trusted compute can be a Lakehouse cluster that will connect to catalog, and it will build a connection based on a technical user. And that technical user will probably have super admin rights to read everything. But now we have a concept of trusted compute. So we will trust the Lakehouse cluster that it can just go and read data and filter that for us. But the information should be provided to that read compute to Lakehouse somehow from outside. And that outside system would be catalog as well as again. And catalog can tell, okay, so you have now user A, and user A is from Germany, so please apply the filtering for this user and show only data from Germany. And that's the way how it can be solved today. So that's more or less accepted, I would say, or is hopefully is going to be accepted for the community, because the other solution are, let's say, they're more expensive. So you can go and try to encrypt, but then it's not really easy. So it's more expensive to decrypt, and then there's not really easy things to rotate keys and do all that stuff. Or the other concept is, let's go and try to materialize views. So what we can do, first of all, maybe we can just create a view with where clause, and that view is going to be materialized only for Germany, for instance, or it is going to be partitioned by Germany, and we will try to give you access to a partition. So something like that. So you have this type of concept.
But I guess if I understand what you're saying, so first of all, you've got this notion of trusted compute means that you're mediating access of the query engine to the files. But it still seems like a lot of this model has to reside in query engines like Trino uh, or ClickHouse, because it's just so fine grained. First of all, it's very fine grained.
Yeah.
Second of all, a lot of authorization is actually a query planning activity where you're just adding predicates to queries. So it seems like this is something that's inherently embedded in the query engines. You get sort of general direction from Iceberg and from these these authorization schemes that you're discussing,
Yeah.
but it's really the query engine that's going to supply the details and make sure that guy from Germany only sees Germany. Is that a correct understanding of how these fit together?
Well, from my understanding, it's not correct, because what you will find in the big companies, or like in many companies, that they use different query engines.
Yes.
Marketing uses
Yeah.
Trino, sales use Snowflake, and engineering uses ClickHouse. And me as a data security guy, as a CISO, I don't have control on that situation. If I
Right.
will feel like, oh, every query engine needs to follow that rule. So that's not a good idea. It's similar what we have with a central IDP. There is a Keycloak, Okta, Entra. There is a one identity system, and similar is going to be here. So we're going to have a simple, probably, or maybe not simple, but a single authorization system, and that is going to be connected to Catalog, and Catalog can provide you that information because it's in the center of that Lakehouse. It's a central component. And you as a query engine, you will connect to Catalog as you do today to get the vendor credentials. And you as a query engine, you will connect to Catalog and get the policy that you need to apply on your planning and have some kind of partition pruning and so on. But the information itself is not going to be managed by query engine. You will just be executing that information that you will get from outside.
Yeah, that's a great point.
Yeah.
Okay. Cool. So this is a fascinating topic. Let's talk a little bit more about Lakekeeper itself. What are the components of Lakekeeper, right? Like, how do I use it? Besides some of these things that we've already been talking about, like, what would the other high-level benefits of it be?
Yeah, maybe let me give kind of a very brief introduction what Lakekeeper is, right? So, as I mentioned, we have that architecture of storage, compute, and catalog. And Lakekeeper is this catalog, which is a REST catalog. So in Iceberg, we have like before REST and after REST. In before REST, we have Hadoop, Hive Metastore, Nessie, JDBC, all the different catalogs. And the problem and the issue was like, oh, now I have a catalog, and now me as a client, like ClickHouse or Trino or whoever, needs to go take that jar file and somehow deploy that. So it was very complicated. Let's put it that way. And then luckily the Apache Iceberg community said, okay, let's create a REST specification. And for everyone maybe who listens, there are four specification: table specification, view specification, the puffin specification, and REST catalog specification. And now everything what we need to do as a client, as a query engine, to deploy that REST specification. But in order to have a REST specification now, we need some entity, and that is exactly the catalog. And we started last year. Again, it wasn't a plan like to build a catalog, but it happened. We said like, oh, let's build a catalog. So it couldn't be that difficult, right? So totally underestimated the issue. But we started to build a catalog, and we said, now we can actually build a REST catalog. And we started building our catalog. First of all, it's in Rust. So we made that decision. We don't want to use like Java or Go. We said like we want to build something in Rust. And that's why at the end of the end, we have a single binary, and you can run it more or less everywhere. It's, I would say, natively running inside of Kubernetes. There is a Helm chart for that single binary. We provide UI. You can use it for hyperscaler storages. You can use it on-prem storages with vendor credential, with remote signing. And the best thing about Lakekeeper, it is Apache 2.0 license, so you can just take it and use it. There are great examples out there. So like Enterprise DB who took it, and there are different providers using Lakekeeper already. But the best thing is about that you can extend it because it's modular. And one of thing what we developed inside of Lakekeeper is the way how we treat the authorization. And right now, the authorization is not inside of Lakekeeper. It's very close to Lakekeeper. So there is an authorizer trait. And you can actually go and rewrite that authorizer trait for your authorization system. We implemented that with OpenFGA, planning now to provide the open policy agent. And I know it's super easy actually to extend it to your own authorization system. So you don't need to run it like multiple authorization system. Well, that's Lakekeeper, and everyone can just go and try it out. But getting back, like why and what is happening about Lakekeeper? Maybe one additional historical kind of disclaimer about what happened. So the last year we had a discussion. Oh, we need a catalog because catalog was responsible to point to a current state of a table. So a client like every query engine can go to a catalog and ask, okay, what do I need to read? Which Parquet files do I need to read to get the current state of the table? By end and beginning of 2025, we saw some kind of evolution from a catalog to metastore. A company started to add some fine-grained access control, some additional thing, and we started to speak about metastore, and especially to get maybe a kind of a rate of confusion with a business catalog like Data Hub, something like that. So it's a different type of a catalog. And today we do not speak more about the metastore, but we do speak about the control plane. That's why, Robert, as I just described, if you have different control query engine, you want to go to a single control plane to have a control on your authorization system. And that's something what we have. And that's what Lakekeeper is. It's a data control plane for your Lakehouse. And as of now, we support Apache Iceberg.
Okay. Let's talk a little bit more about what that means. Like, what is a control plane for my data? So one of the things I've read in your marketing is this idea of actionable metadata. So can you maybe explain what that is?
Oh, yeah. Like if you look at the metadata for the last, I don't know, 20 years, it was kind of a necessity. Oh, yeah, we need somehow to treat the metadata, to document the metadata. And, like the classical example is the data owner. And there's, oh, Jon Snow owns the customer table. Like, oh, let's go to John and ask about the change of a table. Well, John left company for 2 years. And like, okay, so who is owning the table? We don't even know. So what are we going to do with that? And the other classical thing is I'm data engineer. I have a table. Oh, I need to make alter table, drop that table. It's too big. I don't know who is using that one. And what I do, and I had a kind of a conversation with one person, and he told me, I did it at the table. 1 hour later, a business user was on my desk, small as screaming because they had like a deal in $1 million that relies on that data. And the thing is about that the relationship between data consumer and data producer is not kind of like documented, enforced, existing. And that's the whole idea. What we say on a actionable metadata, that to solve those problems and to keep your data pipelines upstream stable, we need to have a different way how we treat the metadata. And one of things what we right now actually building inside of Lakekeeper, what we call computational governance, is exactly to solve the problem that the data producer and data consumer know each other, and what data consumer can do, he can put through a data contract, a constraint, or SLO, stable schema. So if me as a data owner for Lakekeeper can run an alter table, I'm not able to run that operation because Lakekeeper will go and check, oh, there is a consumer of that table, you cannot do that. And the Lakekeeper is the only place where you control that operation. So you don't want to have a post-mortem system. You want to have a preventive way to do stuff.
Right. No, that's a great point, because I think at least some of us have been that person who dropped the table. I spend a lot of my life trying to avoid that conversation. So
It's a nice one, right?
Yeah. So this is a totally fascinating area. There's one area that you haven't talked about too much yet, and that's performance, because I think it's well known that, so for example, you have metadata file explosion, a well-known problem with Iceberg. You have sort of compaction, things like that. So how does Lakekeeper help allow Iceberg to become more performant for users, particularly around things like writes? And do you see yourself, sort of helping people to opening up the gateway to using Iceberg as a real-time storage format, something more like what we see in some of the modern uh, query engines?
Yeah. Well, it depends what is it real time. If you talk about OLTP use
Yeah.
cases, I don't know, right?
Well,
So
let me constrain it. Let me make it. Let me reduce the constraints. So, what's pretty common right now is that if people want to load data to Iceberg and they're just using, Iceberg things that are in the Iceberg orbit, maybe you get dumps of data every 15 minutes. And
yeah,
we have customers that, for historical data, uh, they're okay with that. So event happens in the real world, they see it in 15 minutes. Real time is going to be something, I usually think of it as under a second, but in fact, most customers that I talk to, 15 seconds is good. You
yeah,
have a problem, you have a trace that's relevant to a problem that you're seeing in a live system. If you can see that trace in 15 seconds, that's good enough. Now, that's still really, really hard to achieve that level of latency in Iceberg. And I'm just wondering, do you see catalogs as providing a path to helping people to get there so that they can just go straight to Iceberg and not have like Lambda architectures that's
yeah.
stored in two places for these different
Yeah,
SLOs?
yeah, yeah, absolutely. That's quite interesting use case, and especially like if we can kind of limit to attach on the mode, so it's not
Yeah.
a kind of a CDC type of. Oh, I would love to have here upserts and deletes and something like that. So it's a classical IoT clickstream, and we would just want to add
Yeah.
some data.
Yep.
And there are two things what at least we need to think of. It's one is on the data side, which is more tied to a query engine that is going to write the data, and another one is on a catalog side, and especially on a catalog side, which is responsible to create a metadata JSON file, right?
Hmm.
So if you look at Lakekeeper, it's quite interesting. So what we kind of unintentionally probably achieved is through Rust. Even that is a simple thing that allows us to be very quick on the operation. So
Hmm.
if you like how Rust performs, it's like undisputable thing that we can run faster than something what uses a GDN. The other additional thing that is quite interesting comparing Lakekeeper with other catalogs is if you look, we use Postgres as a database to store our state, and we use a third normal form. So we don't need every time if you do some change to rewrite the whole metadata JSON
Yeah.
file inside of our state, which is way faster if you need just to have a simple update somewhere.
Right.
And only those two things allow us to be very fast on a commit. And I got some feedback that we are way too fast on performance tests comparing with our catalogs, that they need to actually kind of to slow down Lakekeeper. But getting to a high volume uh, kind of like input, we would say it is easy to use Lakekeeper, especially because Lakekeeper itself is stateless, and if you're on Kubernetes, you can just go and add more ports and just kind of like be to scale the whole deployment. It's why it's quite interesting on that side. And now feedback from some customers out there, they use well, it's a very small, I know, like 50 MB ports, 3 ports running in their cluster, and they can handle a huge amount of commits. I don't have a number yet. Probably what we need to do on our side at Vakamo is just to run some benchmark to see like
Hmm.
exactly what is happening here. But
Hmm.
like that's something what we can achieve. The interesting part, what we're building in Lakekeeper Plus, is additional features around the maintenance of your table. So what
Hmm.
we can probably think of, like, okay, now we have a process like, let's say, Kafka Connect, and Kafka Connect is writing like every 15 seconds small file. So we will end up with huge amount of metadata, huge amount of small Parquet files. And now what we can do in Lakekeeper Plus, we can actually run the maintenance job. We can run expire snapshots. We can run the compaction jobs. And we developing that all in Rust as well. So what we want to do, we want to achieve the compaction driven by Rust. That
Yeah.
is going to be, again, more efficient compared like to Spark Java. And we will see. Maybe ClickHouse is an interesting solution written in C++, so you can kind of like run that as well. That would be interesting to see.
Yeah, that's an interesting topic. But what I hear you know, when you're talking about the metadata management and storing it in a database and being able to make updates quickly, I kind of hear some echoes of what Hannes Mulaisen is saying at DuckDB Labs, which is like, look, these are database functions. We shouldn't be manipulating a bunch of files on the file system. This metadata needs to be in a database. That's where it wants to live. It, so do you feel like you're, and in fact, he's proposed Duck Lake, which is a,
Yeah.
you know, I just wonder how that matches up with how your vision matches up with this Duck Lake vision of the DuckDB folks.
Yeah. Well, you know, like in life, it's always you have two sides, right? So on a single coin, and same here. We can. I do love the idea that we don't have any meta data files, a JSON, Afro, manifest list. It's all kind of managed by a catalog. And what you as a query engine, you need just to write a Parquet files. And catalog is able to manage that part as well. I don't know if in Iceberg v4 something is going to be changed on the way who is responsible for the manifest and manifest files and for manifest lists, because that's something what we've got with REST, that REST is now responsible for metadata JSON. If catalog is responsible in the future for that part as well, then the question arises, do I need to write them to the blob storage? Or
Right.
should I just keep it that everything inside of catalog, and catalog will manage that through a third normal data model inside of a Postgres, or key value store on Foundation DB or MongoDB, whatever they're gonna choose for that purposes. It's quite interesting. The downside or like the disadvantage on that one, and that was kind of like the initial idea of Iceberg and Delta as well, that you can actually write that information to object storage, and if your catalog gone,
Yeah.
you can actually go and read that file,
Yeah.
despite that you lost your catalog somehow. So you can register your table in another catalog, and therefore that's kind of like the thing where I say, okay, yes, there are benefits, but we can lose something. And now we need just to understand, maybe we can even run in kind of a dual mode. So we can say, oh, I have an Iceberg table that should be managed completely by catalog, and me as a query engine just want to write the Parquet files, and that's it. And the other strategy might be, okay, no, we wanna run and write still the manifest files. We will see.
Yeah, this is a really interesting design problem. I mean, because if you push it in the database, you've created a SPOF. But if it's on the file system, you got a bunch of stuff you got to manage. And I think balancing that the performance and particularly the ability to make changes quickly, it seems like we're going to iterate on that one for a little while. I like your idea of kind of having a little bit of both, basically.
Well, which means at the end of the day, we need to write more code, right? So and it's going to be more complex. And I don't know if that idea will be well welcomed.
Yeah.
We'll see.
I'm just curious, what's the biggest challenge? I mean, you guys have a really ambitious goal here with Lakekeeper. What are the biggest challenges that you've had in getting this in getting this built and getting it working?
Well, maybe it's less challenge on our side, but the industry challenge, what I'm just trying to solve with Vakamo, and it's why we called that podcast Without Borders, the agnostic way, is, you know, like I see that Iceberg can actually, well, change the way how we treat the data platform in the future, and which means I can store me as a company in that way. So let me put the hat of a company, of a customer. I'm making a decision just to start to collect my data, and then I will choose Iceberg as a stable format. And first of all, I'm starting on Amazon S3 and I'm storing there. And then I have a use case where I just don't want to, you know, like use and provision any query engine, so I'm fine just to start with Redshift on Amazon because I'm all integrated. Suddenly, I understand that Redshift is not sufficient because my use cases, for instance, can be solved with ClickHouse quite good. And then some new data engineer came into the team, and he just want to use a DuckDB. And then someone is just trying to think from AI perspective, like using Daft, for instance, and they just want to use a model learning and then all that AI training as well. And my thing and my concern is, and maybe kind of like a motivation to the companies, is just to think about that Iceberg has a potential to avoid lock-in to a one vertically integrated vendor or ecosystem, which was quite popular for the last, I don't know, like 30 years. So you started, oh, let's go to IBM. The next one, oh, let's go to Oracle. Then let's go to SAP. And now if I go to all that companies, they have all that different stacks, and they're kind of disparate to get access to the data. And now with Iceberg, you can actually free the whole stuff. And then I know that, for instance, DB2 allows you to export and read from Iceberg. And I don't know about SAP yet, but maybe they're going to develop themselves in that direction. And that means that is a huge challenge today for companies, because everyone want to become a data-driven. And in order to get there, you need to be very agnostic. You're not allowed to have borders. Even like in our daily life, me here in the European Union, I don't need a visa. I can just go in all that different places, right? And same with the data. So your data inside of your company should stay agnostic and not having any technical borders and limitation. And that's kind of a challenge what I would love to highlight, and it's something what we want to solve with a Lakekeeper.
That's great. I do want to be respectful of everyone's time, and I know we were talking just before we went live about how we could talk about this all day, probably do a weekend workshop.
What are you doing this weekend?
Yeah, but so kind of stepping back a little bit, I have one spicy question for you, maybe a little spicy. If you could start over, what's one thing you might do differently with Lakekeeper?
If I would start over, well, probably the awareness what Lakekeeper can be in the future. Like we actually got more or less in November, December about that idea that what Lakekeeper can actually achieve and become. I wish we got that already in April, May. That
Okay.
would probably change the way how we actually started the whole project. Yeah.
Yeah. All right. If I'm listening to this and I'm building a data platform team and I'm evaluating my catalog options, what advice would you give me?
Oh, now let me just play a solutions architect. So what is your use case? What type of a company are you? What do you want to achieve? Are you concentrated on data? Is data your main driver to be innovative and drive revenue? Are you just like, okay, it's nice to have data? Do you want to maybe monetize data in the future? There's so a huge amount of questions. So you cannot general say, oh, go and use Lakekeeper. Well, yes, go and use Lakekeeper. Maybe it's a best answer, but to be honest, like to you, my main answer would be go and use Iceberg. And even with the catalogs today, it is a crucial decision, but I think in the next 6 months, it's not going to be that critical, because we will have a catalog federation feature that will allow you to federate catalogs as well. So you can actually start now using open catalog from Snowflake, and then you will understand like, oh, I need some different catalog, maybe Gravitino, and then Caesar will get to you and say, oh, let's just kind of federate that centrally for us, and then you can take Lakekeeper. So you will end up with catalogs same as you have today with the query engines. That's like the future, and therefore stay agnostic. That's main thing.
All right.
Yeah, that's a really that federation is a really important point. Interestingly enough, we had some experience in the last couple months because we integrated ClickHouse with S3 table buckets, which talk Iceberg, but they use an authentication method that is simply not supported yet in ClickHouse. So what we did was we have our own little catalog. We're obviously looking at Lakekeeper as well, but we went ahead and used our catalog as a proxy
Yeah.
to the S3 table buckets. Boom, problem solved. And I think this is I feel like that's an integration problem that if people haven't gotten into managing data on Iceberg, they're gonna find out about that real fast. And it sounds like you guys are enabling kind of a central point that they can talk to that then can delegate out to these other catalogs. Is that the idea?
Yeah, so first of all, Christian had a proposal in the Apache Iceberg community about the changes of endpoint, and that
Mhm.
I think it's already through or just in a
Yeah.
final stage, and we're happy just to make that contribution. And right now, like every catalog will just go and implement that. And that's something what we see. So again, from a perspective, as Josh, as you just said, I'm a team. I just want to start building Lakehouse. I think the main thing for that team is the execution and trying to avoid the lock-in, and the rest will be just done on the way to building that Lakehouse. Yeah.
I think, yeah, and avoiding lock-in, like I have some opinions about that as sometimes gets overused as a buzzword, but here I think it is so critical. Like we're
Yeah.
talking about our data, like that is where avoiding lock-in is the most important. So yeah, I agree.
Yeah, absolutely. And you know, if you look in the future, so you will start with Iceberg with structured data, and hopefully Iceberg is going to evolve and can provide you everything what you need for your AI data. So and then you will have explosion on that way. And actually, the thing is, and maybe that from a business perspective. So if you haven't avoided that lock-in, so you're locked somewhere. The thing is that your competition is probably has no lock-in, and they can take the best technology out there and just outcompete you and be more productive. And that is something from a business perspective what you need to think about. It's not just, oh, well, it is nice to integrate in one single stack. Well,
Mhm.
probably it's nice, but that is a competition disadvantage for you as a business, because now you need to run. Well, I don't want to just make any comparison in that podcast, but let's say you are on technology A, you integrate it in the whole stack, and then there's technology B, which is going to produce way better results for
Yep.
you, so you can make a better decision. You can't use it. You're locked.
Yeah. Yeah.
And that's it. And you can see how fast right now things are evolving on the market. So and you just will have trouble. You will just like pass the whole innovation on that one. And therefore lock-in is one of the central risks that everyone, and not just from an architecture technical perspective, from a business perspective, needs to have on top of the mind.
Yeah. And I think you alluded to this that, like we talked about performance and you were talking about how, hey, there really is a trade-off between keeping all the metadata in the database where it is you're kind of locked in there versus having metadata in
Exactly.
storage in the specified JSON and Avro formats. Uh, Maybe we don't want to
Well,
give those up too quickly because you can't move.
yeah, but if you will take into consideration the federation,
Yeah.
then you're not locked in anymore on
Yeah. Yeah.
that level.
Mm-hmm.
Yeah. I think that's a great. I think that's a great point, and something that it sounds like people really, really need to keep front and center if they want to stay competitive.
Absolutely. So the decision on the Lakehouse and Icebrook on data, it's not a technical decision anymore. And like
Yeah.
sometimes I would even say there is no such thing as a data strategy. Data is just there to support a business strategy.
Yeah.
That's the whole idea. And if that is inside of a company, then that's going to be a very data-driven company, I would say.
Right.
I think that's the description for this podcast episode.
Yeah.
Yeah, data is just there for your business strategy. I like that. Okay, Robert, anything else you want to ask before we start wrapping up?
Yeah, Victor, this is completely off, sort of out of band, but you talked a lot about history early on, and I really enjoyed that. I'm just curious, who's your favorite historian?
Like, well, I wouldn't say the historian. I pretty much like some people in the history who changed the way how we think and how we do, like, and it can be like simple Einstein, it can be Ford.
Yeah.
They are different people, and I have a bunch of them. But maybe we need to meet somewhere in a beer garden, and then we can just dive in that topic.
Yeah, because I think one of your countrymen, Jakob Burckhardt, was the guy who gave us the art, talking about thinking about things differently. He's the guy who gave us the notion of the Renaissance in Italy as we understand it today. So you guys have some really great
Martin
historic.
Luther
Yeah,
is as
Martin
well.
Luther. Yeah, these are no, but I do think that it's wonderful to get these perspectives, these historical perspectives, as we're looking at these technologies, and also think about how that enables us to predict what's going to come.
Absolutely.
All right, last question for me, Victor. What have we not talked about yet that you're really excited about in the future?
Well, the future is bright, and it's awesome. And we talked about that, and I think it's going to be very interesting how that the whole thing will go on, and especially how the physical and virtual world will actually get together for robotics, and how data is going to drive the whole stuff. So I'm quite happy to see, like, in the future, a robot who runs in my flat and helps me to do stuff, and and is data driven and understands, like me, what's happening right now.
Yeah.
Nice. All right. Where can people find you? Where can people try out Lakekeeper? What do you want to promote?
Yeah. Well, first of all, guys, classic, just on LinkedIn, go and search for Viktor Kessler and you will find me. If you want to write me an email, it's victor@vakamo.com. Lakekeeper is on GitHub. It's Lakekeeper. And guys, please try it out. Give us feedback, and simple, give us a star. That will help us to drive the project. And if you want to contribute, we're open to contribution as well. So everyone who want to write Rust, you who want to just test it out, open the issue, we have documentation. Documentation can be improved always. So write the documentation.
Awesome. I know quite a few people who are itching to write more Rust, so that might be a popular call.
Yeah, I hear it looks pretty good on a resume. So so if you've got that, anybody out there listening who's got that problem, Victor's got a solution for you.
Yeah.
Perfect.
All right. Thank you so much, Victor. It's been great having you. Yeah, we'll have our schedule for next month posted soon.
Thank you guys for
Right.
having me, for a great question, for great talk. Talk to you later. Bye-bye.
Thank you, Victor. Bye.